Hello everyone. In this video, we'll be talking about the free fall, an important topic of the mechanics. So as usual, take out your notebook and pen, and wherever you require, you may pause the video for making your notes. In between the video, you'll be getting few checkpoints for conceptual practice, and their answers can be verified at the end of this video. Okay. This topic starts with the Galileo's observation. Suppose a ball is placed on a smooth horizontal surface and the ball is at rest. How much is the acceleration of the ball? Answer it quick. Simple, 0. Net force on the ball is 0, so its acceleration is 0. Now suppose the ball is placed on an incline. Then ball will accelerate down the incline. If the slope of the incline is kept on increasing, then acceleration down the incline will also increase. So Galileo took few observations. Then one question came into Galileo's mind: how you will get the maximum acceleration for this ball? The answer was simple: tip the incline vertically, like as the last diagram visible on the board. If the ball is falling down vertically, its acceleration will be maximum, and that acceleration is known as the acceleration due to gravity. Getting it? And the motion of the ball is known as the free fall. So Galileo discovered an interesting fact: if the air resistance is small enough to be ignored and the distance of fall is small as compared to the radius of Earth, then all objects, irrespective of their shape, size, mass, density, etc., fall toward the center of Earth with same unchanging acceleration g. Let me prove it for you. Suppose I take up this ball and a piece of paper. Their mass is different, their shape is different, their density is different. Okay. What do you think if I release them simultaneously? Who will hit the ground first? Simple observation. Post your answer quickly in the comment box. I'm going to release them simultaneously. Who will hit the ground first? Okay, I'm going to release them. 3, 2, 1. Let's play it in slow motion. You have observed that the ball hits the ground first and the paper reaches later on. Why? The paper's area was more as compared to the surface area of the ball. So the paper was experiencing great amount of air resistance as compared to the ball. Due to that air resistance, paper was moving slowly as compared to the ball. What if we diminish the air resistance? If we can neglect the effects of air resistance, then Galileo's statement will be a truth. Let's give that a try. I'm taking up another object. Let me bring this Spider-Man and another piece of paper. Okay. Now, this Spider-Man has a different mass and this piece of paper has different mass. Right now, the piece of paper has sufficient area, so it will have some air resistance. It will have the effects of the air resistance if I release it in this form. To diminish the effects of the air resistance, let me crunch the paper. Now the surface area is less. Okay. So the effect of air resistance will be less. Now it can be taken as an idealized motion, what Galileo said. I am going to release them together. Guess what will happen? Who will hit the ground first? The Spider-Man or this piece of paper? Or it's a happy ending, both will hit together. Quickly post your opinion in comment box. Okay, I'm going to release them. Watch carefully. Playing the same video in the slow motion. Watch it carefully. Both are hitting the ground at the same moment of time. So Galileo's observation is truly remarkable. Okay, note down all these things and then we'll go further. Now we are going to define the term free fall. Free fall is an idealized motion in which the air resistance is to be neglected. The distance of the fall is small as compared to the radius of Earth and acceleration due to gravity is taken as constant. Since acceleration due to gravity is taken as constant, we can easily use the equation of kinematics for the constant acceleration. Okay. If someone asks you, what do you mean by the freely falling object? Then your answer should be any object moving under the influence of gravity only is known as the freely falling object. Do not go with the literal terms fall. Few people have a misconception that fall means the ball will always be falling only, then you will call it free fall. No, physics has a broader sense of the free fall. I am taking a few examples. Look at this example, a ball which is released. This will keep on moving under the influence of gravity only. We are neglecting the air resistance. Then this ball is under free fall. Take the another example. This young girl is tossing a ball up while the ball is going up or it is coming down. In both the cases, it is moving under the influence of gravity only. So this is a case of free fall. Let's take another example. Suppose someone is kicking a football. After the person kicks the football, if we are neglecting the air resistance, the football moves under the influence of gravity only. So the motion of this football will also be considered as free fall. Okay. Taking up another example. Suppose the shot is fired from a gun. After the bullet leaves the barrel of the gun, it solely moves under the influence of gravity. So the motion of this bullet will also be taken as the free fall. Taking up another interesting example of free fall, how do the satellites keep their orbit? How do the satellites stay in their orbit? The answer is free fall. It sounds interesting. All these satellites are always falling freely. This is how they keep their orbit. I am going to prove it. Pay attention here. Suppose this is the Earth. Okay, here is the center of Earth, let's say. To launch a satellite in a specific orbit, a rocket will take up the satellite to desired height and then satellite is projected. If Earth is not present in this scenario, the satellite will go over this path. Getting it? But since the Earth is present, it will attract the satellite toward its center. So from this position, the satellite will fall somewhere here. Okay, so the satellite has actually taken up this path. Now the velocity vector of satellite will try to take it straight like this, but again due to the presence of Earth, satellite will fall from this path. So satellite will not go here. The satellite will be actually falling and it will reach here. Actually, it is happening at every moment. I am just making an illustrative diagram to give you the feeling of the things. So satellite is actually going along this path. Now the velocity vector of the satellite tries to take it like this. But since Earth is present, the satellite will again fall from this path. It won't take up this path. It will fall toward the center of the Earth. So the satellite will actually reach somewhere here. Okay. So in this manner, the satellite will keep on orbiting around the Earth. There is one space station orbiting around the Earth, International Space Station. That space station is continuously in the state of free fall, and the freely falling object feel the weightlessness. Their apparent weight becomes zero. That will be taught in detail in the chapter Newton's laws of motion. Right now you can grasp this information that all these satellites are always in the state of free fall. Okay, you may note down this example and then we'll go further. Now comes the next topic. What could be the path of a freely falling object? Actually, freely falling object can move along a straight line, can move along a circle, can move along an ellipse, can move along parabola. I am giving you few examples. Suppose this marker is released. What is the path of that marker? Straight line. Another example, this marker is thrown up. While it was going up, its path was a straight line. Now I am throwing the marker like this. its path is parabolic. Take another example. Look at this ball. How is the path of this ball? This path is parabolic. We took the example of the satellites orbiting around the earth. Their path is elliptical or their path is circular. So for free fall motion, the path of an object may be straight line, may be circular, may be elliptical, may be parabolic. It depends upon case to case. Here is a nice trick to determine the path of an accelerated object. Statement is pretty simple. The v vector always tries to align itself along the a vector. I am giving you one example. Suppose, let's say a ball is thrown up. Its velocity vector is upward. We know that acceleration due to gravity is downward. So this v vector will try to align itself along the direction of a vector. So how the things will happen? This ball will go up, will slow down because velocity and acceleration are opposite to each other, and will attain a position of momentarily rest. And from that, this ball will fall back again. And when it is falling back like this, you can check the v vector has aligned itself along the direction of a vector. Getting it? Taking up another example. Suppose from some height, a ball is thrown horizontally with some velocity v, and someone asks you what is the path of this ball. You should check only one thing. V vector will try to align itself along the a vector. So the path of this ball will be parabolic. Getting it? Take up another example. From the ground, someone is kicking a football. This is the v vector. Okay. Now this v vector will try to align itself in the direction of g vector. So this path will be again parabolic. Getting the trick? It's a simple and nice one. Let me ask you one great conceptual question. Look at the diagram very carefully. Look at the picture very carefully. This arrow will choose which path? Quickly post your opinion in comment box. The answer is simple. It will choose the third path, because if you check carefully, only along the third path v vector is trying to align itself along the direction of a vector, means acceleration due to gravity. Getting it? When you will get the first path as your answer? Can you tell in what possibility, in what case you can get the first path as the answer? Correct. If there is no gravity, then the arrow will keep on moving straight. I hope you got this trick. Note it down. Then we'll go further and we'll talk more about the magnitude of the acceleration due to gravity. Okay? The magnitude of acceleration due to gravity nearby the Earth's surface is taken as 9.8 meter per second square, or 980 centimeter per second square, or 32.2 feet per second square. Okay. For making the computation simple, we consider the g approximately equal to 10 meter per second square or pi square meter per second square. How it simplifies our calculations? Pay attention here. Suppose in some computation you see data like this, root 10g, and that g is equal to 10 meter per second square considered, then this can be written as root 10 into 10. So the answer will come out to be 10. Okay. Suppose there is some computation 4 pi square divided by g. Then looking at this data, we can cancel out the pi square and g. Answer will come out to be 2. These are approximated answers, but for our calculation purpose, these numbers are fine. It actually means 9.8 meter per second per second. Per second means 1 second. Suppose we release a ball at t is equal to 0. In 1 second, the velocity of the ball will change by 9.8 meter per second. So if I ask you at t is equal to 1 second, what is the speed of this ball? You can directly tell in 1 second the velocity changes by 9.8 meter per second. So here the speed will be 9.8 meter per second. Getting the idea? If I ask you at t is equal to 2 second, how much is the speed of this ball? In next 1 second, the further addition of 9.8 meter per second, so the speed will become 19.6 meter per second. I hope you understand it. In the questions, many times the value of g is given to us. We should use that value. And if the value of g is not given, we should use our own intuition. If you see the numbers like these, then we should be taking up g as 9.8 meter per second square. Or if you see such kind of scenario, a ball is thrown up with a speed of, let's say, 50 meter per second. Which value of g you should prefer? Simple common sense. In this case, we should prefer g as 10 meter per second square. What is the meaning of 10 meter per second square? It actually means 10 meter per second per second. In 1 second, the velocity will change by what amount? 10 meter per second. Okay. If I ask you how much is the velocity of this ball at t is equal to 1 second, your answer should be actually 40 meter per second. You understand it? Out of 50 meter per second, in 1 second, the change was in this direction and that change was 10 meter per second. Okay. So at t is equal to 1 second, the speed is 40 meter per second. If I ask you what is the velocity at t is equal to 2 second, what should be your answer? It will be 30 meter per second, because in next 1 second, velocity decreases by 10 because acceleration is in this direction. I hope you get the meaning of g. The same things I can explain in another way. This 9.8 meter per second square is some acceleration, and in the direction of acceleration, the particle always gets some extra velocity. How much extra velocity it will get? That will be decided like this. In 1 second, the particle will get extra velocity of 9.8 meter per second. Pay attention again at this example. T is equal to 0. The particle was released, so its initial velocity was 0 and the direction of acceleration is downward. So in this direction, every second it will get the extra speed of 9.8 meter per second. So in 1 second, it will get how much speed? 9.8 meter per second. In next 1 second, it will gain extra 9.8 meter per second. So this 9.8 meter per second plus extra 9.8 meter per second, the data is 19.6 meter per second. Let me ask you another conceptual question. If I ask you what is the velocity of this ball at t is equal to 0.5 second, then what should be your answer? Use this thing. In 1 second, you get the extra velocity in the direction of acceleration as 9.8 meter per second. So in half second, how much extra you will get? 4.9. So the answer should come out to be 4.9 meter per second. I hope you understood that. Taking up the same example here. So 50 was its initial velocity, but during this period it gained 10 in the downward direction. So what is the net resultant here at t is equal to 1 second? 50 up, 10 down, answer is 40. Now look at this moment, particle is going up. Here at t is equal to 1 second, its speed is 40 meter per second. Okay. And for next 1 second journey, it will gain how much extra in the downward direction? 10 meter per second. So at t is equal to 2 second, what should be the net speed? 30 meter per second. 40 meter per second was in upward direction, gained extra 10 meter per second in this duration. So the resultant here will be 30 meter per second. I hope you got this insight. While solving the numericals, you can easily use this approach. It makes your calculations fast. Suppose for this example, if I ask you when this velocity will become 0, starting from t is equal to 0, when the velocity will become 0. Think about it quickly. Do not use any pen or paper. Do the calculations in your brain. Every second the velocity is getting reduced in this downward direction by 10 meter per second. So in 1 second it got reduced by 10. In next 1 second again got reduced by 10. So reducing this entire 50 to 0 will take how many seconds? 5 seconds. Getting it? Note down all these things, then we'll proceed further. If you understood all the previous concepts very well, you can easily answer this problem. Give it your best shot. I am awaiting for your answers. Okay, I am simplifying the things. The ball A has the initial speed 15 meter per second in the upward direction. The ball B has the initial speed 10 meter per second in the upward direction. Ball C has the initial speed 3 meter per second in the upward direction. Looking at this data, what value of G we should choose? Everyone knows G should be taken as 10 meter per second square. Is it okay? It means what? Every 1 second, the 10 meter per second extra velocity is added in the downward direction. So if this is the picture at t is equal to 0, at t is equal to 1 second, how much should be the velocity? For A, 15 meter per second was upward and extra 10 meter per second has been added in downward direction. So the result is 5 meter per second in upward direction. Okay. For B, what should be the result? Already it had 10 meter per second in upward direction and extra 10 meter per second has been added in 1 second. So this 10, that 10 nullified, its velocity is 0. It is at rest. Okay, momentarily rest. And C, 3 upward, 10 downwards. So net effect will be 7 meter per second in the downward direction. Now you can easily write the order of the speeds. The VC is maximum, then comes VA, at last comes VB. VB is momentarily 0. Clear? Simple and easy question. I hope you all got the correct answers. Let me ask you another conceptual question. If I change the masses of these balls, what will be impact on your answer? Think about it and answer it. The answer is there is no impact of the changing mass because these calculations are independent of the mass. Okay. So if we increase the mass or if we decrease the mass, we change the mass, the answers will remain unchanged. Got it? Note it down. Let's take up an example. Suppose a ball is released from the top of tower at t is equal to 0. Its initial velocity is 0 and its distance from the hand is also 0. Okay. Now at t is equal to 1 second, how much should be the velocity of the ball if the acceleration due to gravity has been taken as 9.8 meter per second square? Answer is simple. Every second it will gain the speed 9.8 meter per second in the downward direction. So at t is equal to 1 second, the speed will be 9.8 meter per second. What will be the speed at t is equal to 2 second? Answer is simple. Again, a gain of 9.8 meter per second. So the speed will become 19.6 meter per second. Okay. What is the speed at t is equal to 3 second? Again, a gain of 9.8 meter per second. The speed will become 29.4 meter per second. I request you to try it further for few more moments of time. T is equal to 4 second, 5 second, 6 second. You'll learn it. Done? Next information. If someone asks you how much is the distance traveled by the ball in the time interval 0 to 1 second, what should be your answer? Actually, it should be 0 plus 9.8 by 2 into 1, which results into 4.9 meter. You remember I am using which formula? Correct. S is equal to U plus V by 2 into T. U is 0 for this interval. V means the velocity at T is equal to 1 second, which is 9.8 meter per second, and the time interval is 1 second. Okay. Suppose you require the distance traveled by the ball in the time interval 0 to 2 second. Then what should be the data? 0 plus the speed at 2 seconds is 19.6 meter per second, and this time interval is 2, so it is 19.6 meter. I hope you get this. Okay, if I ask you the total distance traveled in the time interval 0 to 3 second, what should be the answer? 0 plus 29.4 divided by 2, and the time interval is 3. Doing the computation, it comes out to be 44.1 meter. Is it okay? Let me ask you another conceptual question. The distance traveled in the second, how we can obtain that one? It's easy actually. To obtain the distance traveled in the second, what you should do? Total distance traveled in the time interval 0 to 2 second minus the distance traveled in the time interval 0 to 1 second. Do the computation. 19.6 meter minus 4.9 meter. So it comes out to be 14.7 meter. I hope you get it. Okay. Let me ask you another question. What is the speed of the ball at t is equal to 1.5 second? Answer it quick. At t is equal to 1 second, the speed was 9.8 meter per second. And in next 0.5 second, how much is the addition in the speed? In the 9.8 meter per second, the extra addition in half second will be 4.9 meter per second. Getting the idea? So this will come out to be what? 14.7 meter per second. I hope you understand this. Another question. What is the acceleration at t is equal to 3.7 second? Or if I ask you what is the acceleration at t is equal to 1.5 second, the answer will come out to be 9.8 meter per second square only in the downward direction. Getting the idea? I request you to pause the video here, note down all these things carefully and formulate few such questions and try to answer them yourself, such as how much is the total distance traveled by the particle from the time interval 0 to 7 second? How much is the distance traveled by the particle in the 5th second? What is the velocity of particle at t is equal to 9 second? What is the acceleration at t is equal to 5.5 second? Give it a try, you'll learn a lot. Let me ask you two great conceptual questions related to this problem. Number one, from the bottom, with what speed a ball should be thrown upwards so that it can reach to the top of tower? Looking at this picture, you can easily answer. The correct answer is 29.4 meter per second. Okay. In such problems, there is a time symmetry as well as the speed symmetry. I'll reveal that in the upcoming calculations in detail. And the second good conceptual question, if you compare the speed of the ball at the lower altitude and the higher altitude with respect to the ground, what you can comment about the speed? Correct. In such questions, the speed of ball is always more at the lower altitudes. This is a super trick in solving many questions. It will help us out. For example, let's take the next question. Note it down. Using the previous tricks, we can easily answer it. The correct answer is the distance between these two drops will always keep on increasing. Why? Let me prove it. Now, who is at lower altitude with respect to the ground? We can easily tell that drop 1 is at lower altitude with respect to the ground. It means the speed of the drop 1 will always be greater as compared to the speed of drop 2. What I can say, V1 is greater than V2 at any moment of time. If V1 is greater than V2 always, it means the distance between these two drops will keep on increasing. Here is the next interesting question. Again, you can use the previous trick and obtain the answer quickly. So take your time and give it your best shot. I'm awaiting for your answers. Okay, I hope you are done with your calculations. Using the previous trick, the speed of ball is always greater at lower altitudes in all such problems. It means along which window we will have the greater speed. It's simple, the lowest window, and I am naming it window number 4, starting from the top 1, 2, 3, 4. Okay. So at the top of the windows, if we assign the speeds as u1, u2, u3 and u4, the correct order will be u4 is maximum, then u3, then u2 and then u1. Okay. Now we need the time taken in crossing all these windows. Since at lower altitudes the speed of the ball is greater, it means the time taken in crossing the window 4 will be lowest and the time taken in crossing the window 1 will be maximum, because at higher altitudes the speed is less. Then for traveling some distance the ball will require more time. I hope you get this. Now comparing the acceleration due to gravity is constant. Done. Last question is asking the order of the change in the speed. For that we can use A is equal to delta V by delta T. And using this computation we can say that change in the speed is equal to A delta T. It's a unidirectional motion, so we can easily utilize this formula. A is constant for all these scenarios and delta T is then directly proportional to delta V. Now looking at the order of delta T, we can easily determine the order of the change in the speed. Delta T is lowest for the fourth window. It means change in the speed for the fourth window will be lowest and the change in the speed for the first window will be highest. I hope you understand that order. Okay, you note it down. Here is the next variant of the previous problem. The ball is thrown from the bottom. Then you need to answer these questions again. Give it a try. I hope you got your correct answer using the trick. The speed of ball is always higher at the lower altitudes in all such questions. So if we assign the speed at the top of each window as u4, u3, u2 and u1 while the ball is going up, we can easily write the order. In this scenario the u4 will be greatest because the window 4 is at the lower level. Then comes u3, then comes u2, then comes u1. Window 1 is at higher altitude. At higher altitudes the speed of ball is less. If u4 is greater, then in crossing the window 4 the time taken will be least. It means delta T4 is least and delta T1 is maximum. At higher altitudes the speed of ball is less, so covering that same distance, the same length of the window, it will take more time. So completing that remaining order here, delta T3 and delta T2. Okay. Now if we talk about the acceleration, that we already know, acceleration throughout this journey is equal to g only. Next part is asking us the change in the speed. We know that change in speed is written as A delta T. A is constant, so delta V is directly proportional to the delta T. So I can write here delta V4 is less, then delta V3, then delta V2, and at last we should write delta V1. Okay, at the higher altitude the speed is less as well as the change in the speed will be less for a given distance. Here is the next beautiful question. If you have understood all the previous concepts very well, you can answer all these parts easily. Pause the video here and give it a try. You'll learn a lot. I hope you are done with your calculations. I'm doing a detailed analysis of the entire problem. Then you can match your answers very easily. Okay. Here we consider the ground. A ball is thrown upwards with a speed of 50 meter per second. And this moment we consider as t is equal to 0 second. Acceleration due to gravity, we know we should take 10 meter per second square. Looking at this number, this will be the best choice. Okay, and what does it mean? 10 meter per second every second. Okay, someone asks us what is the speed of the ball at t is equal to 1 second. What should be our answer? We know that it will be 40 meter per second. Because in 1 second the speed will change in this direction by 10 meter per second. Extra 10 meter per second speed is added in this direction every second. So 50 up, 10 down, it will be 40. Next 1 second means t is equal to 2 second. If someone asks you what is the speed of the ball, what should be your answer? 30 meter per second. Okay. T is equal to 3 second. The speed of the ball will be 20 meter per second. T is equal to 4 second. The speed of the ball will be 10 meter per second. And here comes t is equal to 5 second. The speed of the ball will be 0. The ball is momentarily at rest. Okay. Now we can answer about the acceleration. Once the ball is leaving the hands and it remains in air throughout that journey, the acceleration of the ball is g only and its direction is always downwards. Okay. Few students have a misconception here. They think here velocity is 0, so acceleration is 0. No, acceleration here is also g only. Okay. Because of that acceleration only, the direction of velocity vector is getting changed. I told you, v vector tries to align itself in the direction of a vector for an accelerated object. We have seen that thing. So just before this moment, t is equal to 5 second, if you check, the direction of v vector was upward, and just after this moment t is equal to 5 second, the direction of v vector will become downward. So that is happening because of the gravity only. If you have misconception that g here is 0, if g here is 0 and v is also 0, the ball will hang here, it will never fall down. Getting it? So clear out that misconception that acceleration at the top is 0. Acceleration is not 0, velocity is 0 momentarily. Okay, fine. Now we can answer the next question. How much is the change in the velocity every second? Change in the velocity every second is 10 meter per second in the downward direction, whether the ball is going up or coming down. Okay, t is equal to 6 second. If we want to draw the diagram, the speed of the ball will be 10 meter per second. See the interesting thing, at a given height from the ground, the speed while going up and while coming down, they are same, they are equal. It's an important thing to note. T is equal to 7 second. The speed will become 20 meter per second. I hope you understand why that is happening. Every second, the speed will now increase by 10 meter per second. T is equal to 8 second. The speed is 30 meter per second. T is equal to 9 second. The speed is 40 meter per second, and then comes t is equal to 10 second. The speed is 50 meter per second. Getting it? If I ask you what is the speed at t is equal to 11 second, then your answer should be 60 meter per second. T is equal to 12 second. The speed will be 70 meter per second, and so on until it hits the ground. You can utilize this for doing the calculations of the speed. Okay. Now we can find the distances traveled in every second. For example, if we want to calculate the distance traveled in this interval of time, we should be using which formula? Correct. We know that S is equal to U plus V by 2 multiplied with the T. For this 1 second time interval, U is 50 and V is 40. So 50 plus 40 means 90, and then divide by 2, it will give you 45 meter. I hope you understand the calculation. 50 plus 40 by 2 into time interval is 1 second. Quickly answer this distance. 40 plus 30 means 70 divided by 2 into 1. So this distance is 35 meter. Then for this interval of the time, the distance traveled is 30 plus 20 divided by 2 means 25 meter. Next, this moment of time, t is equal to 3 second to 4 second. 20 plus 10 divided by 2. So it means 30 by 2 into 1. So this distance is 15 meter. And from here to here, the distance traveled will be 5 meter. I hope you get it. The same distances will be traveled while coming down. It means from t is equal to 5 second to 6 second. If someone asks you, the particle will travel how much distance? Your answer will be 5 meter. Then it will travel 15 meter in this second. Okay. Then it will travel 25 meter in this second. Then it will travel 35 meter in next second. Then it will travel 45 meter in the next second. Here is one interesting thing. If you note down, check the ratio of these distances traveled every second. What is that ratio? 1 is to 3 is to 5 is to 7 is to 9. The ratio is lying in the odd numbers starting from the unity. That is known as the Galileo's law of odd numbers. On that topic, there is a complete video. You can check that in the playlist. Now, the next important thing to note down, the distance traveled in the last t second of its upward journey is independent of the initial speed. How? Let's pay attention. Suppose this time interval is t second and we want the distance traveled. So we can use S is equal to Vt minus half At square. What is the velocity at the top? 0. So this term vanishes. Upward direction we are choosing positive and the downward we are taking as negative for computation purpose. So I am doing the replacement here. Minus half A is minus G and then T square. So distance traveled in the last t seconds of the upward journey is always independent of the initial speed. Getting it? To travel the same distance, it will take same time while going up and while coming down. Suppose someone asks you, traveling 60 meter of this distance, particle takes how much time while going upward? You can check. It will take 2 seconds to travel this 60 meter distance. Then to travel this 60 meter distance back while going downwards, it will again consume 2 seconds. Understanding the concept of symmetry? Okay. Note down all these answers first and then we'll go further. Here is a simple and interesting problem. You can give it a try. Okay, the correct answer is both the objects will hit the ground with the same speed. Why? Pay attention. Suppose this ball is thrown with some velocity v. It will go up and will attain momentarily rest somewhere here and then it will fall back. The moment it will reach back to the same position here, what will be its speed while going downwards? Correct. Its speed will be v again while going downwards. We have already seen that. Now, Look at the ball B. For ball B, the speed is already v. Since these two are having the same speeds at this level, so they will be hitting the ground with the same speed. Getting it? Simple and easy question. Note down the answer, then we'll go further. Here is the next interesting question. If you wish, you may pause here and give it a try. Then I'll be solving it on the board. Okay, the hint lies in the language of the question itself. It travels equal distances in the third second and the fourth second. Suppose a ball is going up. If you check the moment the third second and you check the moment fourth second, will it travel the equal distance? No. Every second the distance traveled will keep on decreasing, that we have seen in the previous computation. Or this ball is falling from the top and then going down. So while falling down in third second and in fourth second, will it cover the same distance or different distances? We know while falling down every second it will cover up more and more distance. So this is not the case. This is not the case. Then what is the possibility? There is only one possibility. This should be the moment t is equal to 3 seconds, where the ball is at momentarily rest. Here should be the moment t is equal to 2 seconds, t is equal to 1 second, and the ball is projected up at t is equal to 0 second. Then this will be the third second. At the end of 2 seconds, the moment of the third second will start, and this will be the fourth second. I hope you understand it. And then distance traveled in the third second and the fourth second will be equal. This ball falls from rest for this journey. Then in 1 second, how much distance it will travel? We know it will travel 5 meters. We can compute it. U is 0 for this journey. Acceleration is taken as 10 and time is 1. So S comes out to be 5 meters. Clear? Then we can use the Galileo's law of odd number if we require the further distances. This should be 15 meters. This should be 25 meters. Simple computation. While going up, you can use the symmetry. This will be 15 meters. This will be 25 meters. Now, we can easily answer how much is the maximum height of this ball with respect to the ground. 25 plus 15 plus 5. Getting it? 45 meters is the height of this ball above the ground. How much is the time of ascent? You can easily tell time of ascent is 3 seconds. How much is the time of descent? It will also be 3 seconds. What is the total time of flight? It will be equal to 6 seconds. Now, can you answer what is the speed of the ball at this moment? The moment of projection? It's simple. In 3 seconds, if the speed is becoming 0, this should be 30 meters per second. This should be 20 meters per second. This should be 10 meters per second. If someone asks us, the ball will be hitting the ground with what speed? What should be our reply? Same 30 meters per second. Okay, you note it down.